What is meant by d by d theta? Differentiation with respect to theta. D by dx of x power n is what? N into x power n minus 1. For example, here if they don't give base, we call it as log base e only, and answer is 1 by x. So 6 trigonometric functions you have studied: sine, cos, tan, cot, cosecant and secant. 7 is a number. All numbers are what? Constant. And rule 2 says that d by dx of constant is 0. Welcome to the session, dear students. So in today's class, we will be studying important topic, that is differential calculus. I will be teaching you the basic formulae. Become thorough with the basic formulae. Once you are thorough with the basics, then we can start with the problems. In my last session, I taught you first principles, method of first principles. Now we don't derive, we apply what we derived. To apply what we derived, first we will make a list of formulae. So now standard formulae. So before we go to the formulae, the very first thing is d by dx. We read this d by dx as what? Differentiation with respect to x. What is d by dx? Differentiation with respect to what? X. Similarly, if I give you d by d theta, d by d theta, we read this as what? Differentiation with respect to what? Theta. D by d theta means derivative with respect to theta. Or d by dt. D by dt means what? Differentiation with respect to t. I am writing in short form. D stands for differentiation. WRT means with respect to t. Similarly, we can differentiate with respect to the given variable. Now this is d by dx, differentiation with respect to x. What we read this as? Differentiation with respect to x. D by d theta, we read this as what? Differentiation with respect to theta. D by dt, we read this as what? Differentiation with respect to t. So first, this is the notation you should be thorough with. What is meant by d by dx, my dear students? Differentiation with respect to x. What is meant by d by d theta? Differentiation with respect to theta. What is meant by d by dt? Differentiation with respect to t. So d by dx of sin x means what? Differentiation of sin x with respect to x. Differentiation of sin x with respect to what? X is what? Cos x. Directly we will write. And we have done this in method of first principles. We derived. Now we will not derive. Directly we will use the formula. So now how to read this? Differentiation of sin x with respect to x. Similarly, d by d theta of sin theta means what? Differentiation of sin theta with respect to theta is what? Cos theta. Here x is the variable with respect to x. Here theta is the variable with respect to theta. I hope all of you understood. What is meant by d by dx? Differentiation with respect to x. Now, standard functions. So standard functions, the very first function is d by dx of x power n. What is d by dx of x power n? N into x power n minus 1. D by dx of x power n is what? N into x power n minus 1. For example, if you have d by dx of x power 5, now it is in the form of x power n. Differentiation of x power 5 with respect to x, it is in the form of what? D by dx of x power n. What is d by dx of x power n? N into x power n minus 1. So d by dx of x power 5 is what? 5 into x power 5 minus 1. So it will become what? 5 into x power 4. So we can use this formula. So first you have to be thorough with this formula. What is the first formula? D by dx of x power n. What is differentiation of x power n? N into x power n minus 1. So like this, whenever they give problem, here this is called as variable power constant. In the power we have n. N is what? Constant. So what is the first formula? D by dx of x power n. What is derivative of x power n? N into x power n minus 1, where n is constant and x is variable. So this is the first formula. So become thorough with the very first formula. So what is d by dx of x power n? N into x power n minus 1. For example, d by dx of x power 5, 5 into x power 5 minus 1, that is 5x power 4. D by dx of root x. See, d by dx of root x is 1 by 2 root x. And d by dx of root x, I can use the first formula. If you want to find d by dx of root x, can we write root x as d by dx of x power half? Now it is in the form of d by dx of x power n. All of you know what is d by dx of x power n? D by dx of x power n is n into x power n minus 1. So now this is in the form of d by dx of x power n. So I can use half into x power half minus 1. So that will become half into x power, take LCM, 2 is the LCM, 1 minus 2 ones are 2. So that will become half into x power minus 1 by 2, or that is half into half x power minus 1 by 2, transfer it down, it will become x power half, or 1 by 2 times root x. So if you do so many steps, you will get 1 by 2 root x, but always will not have enough time to take x power half and simplify. Many times this is one of the standard formulae, so memorize the value. D by dx of root x is what? 1 by 2 root x. And how to derive? Take root as what? X power half, and use the first formula. So d by dx of x power half is half into x power half minus 1. So d by dx of x power n is what? N into x power n minus 1. Similarly, what is d by dx of root x? 1 by 2 root x. D by dx of root x is what? 1 by 2 root x. My dear students, so memorize the first formula and second formula so that we can use the formula wherever required. Otherwise what happens? You have to sit and derive. Deriving each formula kills your time and steps will become more. So that's why both are equally important. What is d by dx of x power n? N into x power n minus 1. What is d by dx of root x? 1 by 2 root x. And d by dx of 1 by x is minus 1 by x square. D by dx of 1 by x is what? Minus 1 by x square. This, see, if they ask d by dx of 1 by x, again 1 by x can be written as, I'll write d by dx of, so 1 by x, all of you know 1 by x can be written as x power minus 1, and it is in the form of x power n. So use the first formula. What is d by dx of x power n? N into x power n minus 1. So here in the place of n I have minus 1, so minus 1 into x power minus 1 minus 1. So it will become minus 1 into x power minus 2, or minus 1 into or divided by x power minus 2 transferred down, so it will become x square. So finally we will get d by dx of 1 by x is minus 1 by x square. Again I am repeating, so don't derive like this and waste your time. Remember these three formulae, all three are standard. What is the first one? D by dx of x power n. What is d by dx of x power n? N into x power n minus 1. D by dx of root x, 1 by 2 root x. D by dx of 1 by x, minus 1 by x square. So memorize these three standard functions. So next, d by dx of log x is 1 by x. What is differentiation of log x? 1 by x. And we have done this using first principles. So d by dx of log base ex is what? 1 by x. D by dx of a per x is a per x log base ea. D by dx of e per x is e per x. So here question and answer both are same. Differentiation of e per x is e per x itself. And derivative of log x gives you what? 1 by x. And derivative of a per x is a per x into log base ea. This, so totally 6 standard functions. So on the board we have what? D by dx of log x. See, if they don't give base, here if they don't give base, we call it as log base e only, and answer is 1 by x. If they give base e, it is considered as base e. If they don't give base e, by default we assume it is base e. If they don't give base, it is assumed as base e. And if they give any other base, then you have to change the base using change of base rule of logarithm. First PUC you should use. So now means, what I mean to say is, if they give log base to x, d by dx of log base to x is not equal to 1 by x. This is not 1 by x. We have to simplify this further. So when we go to the problems, I'll explain that. So now for time being, what you should know, derivative of log x. What is derivative of log x? Derivative of log x is 1 by x. If they don't give base, it means it is base e. So derivative of log base ex is what? 1 by x. And derivative of a power x, a means any constant, that is a power x into log base ea. And derivative of last but important standard function e power x is e power x. It will be e power x into log base ee. Log base ee, all of you know 1. That's why this will be sim. What is d by dx of log x? 1 by x. What is d by dx of a power x? A power x into log a. What is d by dx of e power x? E power x. Now let me discuss the difference. If I give d by dx of x power 3, it is in the form, the first formula. If you refer, what is the first formula? X power n. What is derivative of x power n? N into x power n minus 1. So I can use 3 into x power 3 minus 1. Then what is this formula? A power x. Can I say it is in the form a power x? No, because base is variable. So when to use this formula? When to use this formula means in the base if you have number, for example if you have 3 power x, here please understand base is constant, here power is constant, here base is constant. When base is constant, use a power x formula. What is derivative a power x? A power x into log base EA. What is d by dx of 3 power x? 3 power x into log base E3. Derivative of 3 power x is 3 power x log base E3. Similarly, if I ask what is d by dx of 2 power x, again this is constant power variable. So 2 power x into log base E, A means in the place of A I have 2. So if you have x power number, use first formula, x power n formula. If you have number power x, use the second formula. I hope all of you understood the difference. So now 6 standard functions we have done. How many standard functions we have done? 6. What are they? D by dx of x power n, n into x power n minus 1, d by dx of root x, 1 by 2 root x, d by dx of 1 by x, minus 1 by x square, and d by dx of log x, 1 by x, d by dx of a power x into log a, d by dx of e power x. So these 6 formulae should be on your tongue tip. Whenever you want to solve problems, all the formulae you should be thorough. So if you know the formula, then the problems becomes easy. Then 6 standard functions we have covered. Now we'll go to trigonometric functions. So next we'll discuss what? Trigonometric functions. So 6 trigonometric functions you have studied: sine, cos, tan, cot, cosecant and secant. So derivative of sin x is cos x. D by dx of sin x is what? Cos x. What is d by dx of sin x? Cos x. D by dx of cos x is minus sin x. Derivative of cos x is what? Minus sin x. D by dx of tan x is secant square x. So what is the derivative sign? Derivative sign is what? Cos. And what is derivative of cos? Derivative of cos is minus sign. Here minus sign comes, don't forget. And what is derivative of tan? Differentiation of tan x gives you what? Secant square x. So these are the 3 basic formulae. D by dx of sin x is cos x. Differentiation of sin x with respect to x is cos x. D by dx of cos x is minus sin x. D by dx of tan x is secant square x. Then other 3 functions. Derivative of cot x. So tan x is secant square, cot x is cosecant square, but minus cosecant square. So derivative of cot x is what? Minus cosecant square x. D by dx of secant x is secant x into tan x. Derivative of cosecant x is minus cosecant into cot. My dear students, take a book and write all the formula and memorize and become thorough. Once you are thorough with the formula, then the problems becomes faster. All these things are derived using what? Method of first principles. In my last class, I taught you method of first principles. What is the method of first principles? dy by dx can be written as limit delta x tends to 0 f of x plus delta x minus f of x divided by delta x. This is a method we have discussed. Using this I derived sin x, using this I derived x power n in my last sessions. So after we derive, you have to remember the answers or you have to memorize the formulae. What is d by dx of cot x? Minus cosecant square x. D by dx of secant x, secant into tan. D by dx of cosecant minus cosecant into cot. So in today's session, all the formulas are listed and all the formulas I am again repeating so that you will write the formula, you will become thorough with the formula, then I will show how to apply them. Then in my next session, we will start with the exercise problems. Now, the inverse trigonometric functions. So differentiation of sin inverse x is 1 by root of 1 minus x square. D by dx of sin inverse x is 1 by root of 1 minus x square. Cos inverse x means same but negative. So difference between sin inverse x and cos inverse x is sin. So sin inverse x, d by dx of inverse trigonometric function is 1 by root of 1 minus x square, and cos inverse x negative, and derivative of tan inverse x is 1 by 1 plus x square, and derivative of cot inverse x is minus 1 by x, 1 by 1 plus x square, secant inverse x 1 by x into root of x square minus 1, cosecant inverse x minus 1 by x into root of x square minus 1. So inverse trigonometric functions are also included, but for you people, standard functions and trigonometric functions, you should be thorough for my next session. Next we have other important case called rules. From here you should be very alert, and today's class till now whatever I gave, that formula you have to sit and memorize. So there is nothing there, but here Every rule I'll demonstrate using a formula. Every rule is simple. Once you are thorough with the rules, applying the rules becomes easier. What is the rule? All numbers are constants. All numbers are what? Constant. You take any number, it is constant, whether it is fraction or say 5 is constant because it's a number, or minus 2 is a constant, 3 by 2 is a constant, 1.414 is a constant, root 2 is a constant, pi is a constant. All numbers, we call them as what? Constants. What is rule number 1, my dear students? All numbers are constants. I am repeating, once you are thorough with the rules, problems becomes easy. What is the first rule? All numbers are constants. You take any number, maybe it's positive number or negative number, integer, real number, fraction or rational, irrational, any number you take, all numbers are treated as constant. So I hope all of you are thorough with this. And all alphabets, A, B, C, you take any alphabet, A, B or capital A, capital B or M, all alphabets are constants except these three in our syllabus. X is independent variable, y is dependent variable because we will do dy by dx. So y and x are variables. T is time variable, so we will do rate measures, d by dt. So except x by t, all other alphabets we treat them as what? Constants. So what is the rule number 1? All numbers are constants and all alphabets except x, y, t in the context are treated as constants. So I hope all of you are thorough with the rule 1. Now rule 2. So rule 1 is done. Rule 2. D by dx of k constant is 0. So derivative of constant is what? 0. This is rule 2. Rule 2 is what? D by dx of constant is 0. Listen, my dear students, if you have d by dx of 7, what is 7? 7 is a number. All numbers are what? Constant. And rule 2 says that d by dx of constant is 0. What is rule number 2? D by dx of constant is 0. D by dx of 7 is 0. Or if you have d by dx of b, and you know all alphabets are constant except x by t, derivative of b is also 0. Derivative of m, d by dx of m is 0. Derivative of 2 by 3, d by dx of 2 by 3. 2 by 3 is also what? Constant, 0. So what is the rule number 2? All constants, differentiation of constant is 0. Differentiation of constant is 0. Derivative of constant is 0, or d by dx of k is 0. K stands for constant. Then third rule, d by dx of k into f of x. If you have constant into function, take the constant outside and differentiate the function. D by dx of k into f of x is k into d by dx of f of x. What is d by dx of k into f of x? K into d by dx of f of x. Take k out and apply derivative for f of x. And last but important in this slide, that is d by dx of f of x plus or minus g of x is d by dx of f of x plus or minus d by dx of g of x. If you have sum or difference of two functions, you can differentiate separately. So now to demonstrate these 4 rules, let me take some examples. Let me consider some examples to demonstrate the first rule, all numbers are constants and all alphabets except x, y, t are constant. Second rule, derivative of constant is 0. Third rule, derivative of k into f of x is take k and apply d by dx for f of x. And fourth rule, if you have sum or difference, then you can apply derivative separately. So now observe the first rule, d by dx of 8. What is 8, my dear students? 8 is number, all numbers are what? Constant. So differentiation of constant is 0. And next one, d by dx of 3 sin x I will take. All of you know 3 is what? Number. Number means what? Constant. So if you have only 3, if you have d by dx of 3, it will become 0. But we have 3 sin x, means what? We read this as 3 into sin x. So it is in the form k into f of x. If you have k into f of x, take the constant out. So take 3 outside and apply d by dx for function. What is the function? Sin x. So now this will become what? 3 into derivative of sin x is what? Cos x. So now we got dy by dx. What is dy by dx of 3 sin x? 3 is constant, take it outside and apply d by dx for sin x. We are using rule 3. What is rule 3? d by dx of k into f of x is k into d by dx of f of x. Means d by dx of constant into function means take the constant outside and apply d by dx for f of x. And third rule, so if you have d by dx of, say suppose I have sin x minus log x. So if I want, So there are two functions, one is sin x minus log x. So then you have to apply differentiation for both. Then it will become d by dx of sin x. In between, what is the sign given? Minus. So minus d by dx of log x. That's it. And you know d by dx of sin x is what? Cos x. In between minus, what is d by dx of log x? 1 by x. This is the answer. If you have more than one function, if you have sum or difference of more than one function, then you should differentiate each function. If you have plus in between, you put plus. If you have minus in between, put minus. So these are the 4 rules now. What is rule number 1? All numbers are constants and all alphabets except x, y, t are constant. Rule number 2, d by dx of constant is 0, means d by dx of k is 0. And rule number 3, d by dx of k into f of x means take the constant out and apply d by dx for f of x. Rule number 4 is d by dx of f of x plus or minus g of x is there, means you can apply d by dx for each function. Next we have very important. So in today's class, this is the most important, the last 5th rule and last rule 6th rule, product rule and quotient rule. First we will discuss product rule. Product rule I gave in numbers. So 5th rule is product rule, d by dx of 1 into 2 means d by dx of first function into second function is first function into d by dx of second plus second function into d by dx of first. What is the product rule? First into derivative of second plus second into derivative of first. And if you say first function is u and second function is v, we say uv rule, u into dv by dx plus v into du by dx. So first function into derivative of second function plus second function into derivative of first function. We call this as what? Product rule. When to use? When there are product of two functions. One example I will take. Suppose we have d by dx of sin x into log x. I am repeatedly taking the same. Why? Because you have to become thorough with the formula. So for time being, we will learn, I will summarize or I will revise sin x. What is derivative of sin x, my dear students? Cos x. And similarly, what is derivative of log x, my dear students? Log x is what? 1 by x. So we using this to, now I am writing the formula, but from my next session you should know the formula. Now fine. So now d by dx of sin x log x. I can't write cos x and 1 by x. So this is product of two functions. They will not give, there is product of two functions, apply product rule, they will not mention. You have to observe. When you observe, sin x into log x is there. Sin x into log x means it is product of two functions. Whenever they give product of two functions, you should use product rule. So first function is what? Sin x. And second function is what? Log x. In between into we have. So what is the formula? First function into derivative of second function plus second function into derivative of first function. Memorize this. What is product rule? First function into derivative of second function plus second function into derivative of first function. So what is the first function? Sin x. Sin x into d by dx of second function. Second function is d by dx of log x plus log x into d by dx of first function, log x into d by dx of sin x. So that is sin x into d by dx of log x is 1 by x plus log x into d by dx of sin x is cos x. This is the final answer. First function into derivative of second plus second into derivative of first. First is sin x, derivative of log x is 1 by x plus second is log x into derivative of sin is cos. This is the final answer. I hope all of you understood product rule. What is product rule? If you have product of two functions, you have to use product rule to differentiate. What is the product rule? First function into derivative of second function plus second function into derivative of first function. So I gave a simple example. Now let me take one more problem. We'll see how many of you will understand. So x cube into, say I'll give x cube into e power x, simple. Before I go to e power x, I'll take again I'll take, what is that, easier one, because e power x derivative is e power x. You will get confused. This is, we are beginning with the topic. I'll take a simple one, d by dx of x cube into, again I'll take log x only, because you know what is derivative of log x. What is derivative of log x? 1 by x. and also you know derivative of x cube. What is d by dx of x cube? It is in the form of x power n. What is derivative of x power n? N into x power n minus 1. So d by dx of x cube is 3 into x power 3 minus 1. Just now we have done log x. What is d by dx of log x, my dear students? It is 1 by x. Now d by dx of x cube into log x, if they ask, we have product of two functions. So they will not mention use product rule. You have to decide. How to decide? Check how many functions are there. Here x cube is one of the function of the form x power n. Log x is other function. We have exactly two functions. In between we don't have plus or minus. So we read this as product of two functions. So whenever product of two functions is there, we should use what rule? Product rule. What is the first function here? X cube. What is the second function? Log x. What is the rule? First function into, so what is the rule? First function into d by dx of second function plus second function into d by dx of first function. So first function is x cube into d by dx of log x plus second function log x into d by dx of first function x cube. So x cube into d by dx of log x plus log x into d by dx of x cube, that is x cube into what is derivative of log x? 1 by x plus log x into what is derivative of x cube? 3x square. So now simplify this, you know this will become x square, finally x square plus log x into 3x square, or you can take x square common also. Finally if I take x square common, I will be left out with 1 plus 3 log x. So these are the sample problems I demonstrated to make you understand what? Product rule. Now we'll go with quotient rule. What is meant by quotient rule? Quotient rule means what? Whenever the function is in the form numerator by denominator, whenever the function is rational function, if you have numerator by denominator, numerator one function, denominator another function, if you have, formula is simple. In the denominator, denominator the whole square. In the denominator, denominator the whole square. Denominator into derivative of numerator minus numerator into derivative of denominator. So what is the formula? Denominator into derivative of numerator minus, in the formula, numerator into derivative of denominator by denominator the whole square. So what is the formula? In the denominator, denominator the whole square. In the numerator, start with denominator. Denominator into derivative of numerator minus numerator into derivative of denominator. Write and practice and become thorough with this. For example, if you have d by dx of, we'll take a function that is x square divided by sin x, some function I'll take. So now is it in the form numerator by denominator? X square divided by what? Sin x. X square by sin x. So now I have to differentiate this. To differentiate this, because it is in the form numerator by denominator, you should use quotient rule. What is quotient rule? In the denominator, denominator the whole square. So in the denominator, we'll write, so what is the quotient rule? First we'll summarize. What is quotient rule? Numerator by denominator, if you have, answer is in the denominator, write denominator the whole square. In the numerator, denominator into derivative of numerator minus numerator into derivative of denominator. So now we'll apply this formula. So now it is in the form numerator by denominator. So answer is in the denominator, denominator the whole square. What is the denominator? Sin x. So sin x the whole square. Denominator the whole square. In the numerator, denominator into means what? What is the denominator here? Sin x. So down whatever we have, it is denominator. Sin x into d by dx of numerator, d by dx of x square minus, in the formula we have minus numerator. What is numerator? X square into d by dx of denominator. What is denominator? Sin x. We can also call it as u by v rule. In the denominator v square, numerator v into du by dx minus u into dv by dx. So now denominator into derivative of numerator minus numerator into derivative of denominator. In this problem, denominator is sin x. Sin x into d by dx of numerator. Numerator is x square minus numerator. Numerator is x square into d by dx of denominator sin x. Now simplify this. That is sin x into derivative of x square is 2x minus x square into derivative of sin x is cos x divided by sin x the whole square is sin square x. This is the formula. So now this is the sixth rule. So now all the rules I have covered. Please understand, my dear students, for my next session, you should be thorough with all the 6 standard formulae, 6 trigonometric formulae, 6 rules. I am not asking you to learn inverse. If you are thorough with this, enough. So first I started the class with what? D by dx. D by dx means what? Differentiation with respect to x. Then I gave standard formula: derivative x power n, n into x power n minus 1, root x, 1 by 2 root x, 1 by x minus 1 by x square, log x, 1 by x, e power x, e power x, a power x, a power x into log base a. Then 6 standard trigonometric functions we studied. Derivative of sin x is cos x is minus sin x, tan x is secant square x, cot x is minus cosecant square x, secant x is secant x into tan x, cosecant x is minus cosecant into cot. Then I gave 6 rules. All alphabets are constants except x by t, all numbers are also constants. And second rule is d by dx of constant is 0. Third, d by dx of k into f of x is k into d by dx of f of x, meaning d by dx of constant into function means take the constant outside and differentiate the function. Then I gave product rule. Derivative of product of two functions, you have to use product rule. First into derivative of second function plus second function into derivative of first function. Then I gave quotient rule. Quotient rule is what? Numerator by denominator. If you have rational function, in numerator one function and denominator one function, again you should use quotient rule to differentiate. What is quotient rule? In the denominator the whole square. In the numerator, denominator into derivative of numerator minus numerator into derivative of denominator. So all the 6 rules, 6 standard functions, 6 trigonometric functions become thorough, and attend the next session so that you can do the problems easier. Thanks for attending the session. I'll expect all my students to become thorough with the formula and rules and attend my next session. Thank you.